All right, so all these materials ask you to use some fairly archaic methods of trying to figure out these zeros. And, you know, one of the things, and it's not that they're bad, it's just that this is 2020 when I'm recording this, and I don't know how much of that is really useful in this day and age. Now, we could certainly qualify, you know, verify it, you know, do the theoretical stuff, and then go get the answers and verify them. But what I'm going to do is I'm going to show you another way to do this. Yes, I got to hold you accountable for Descartes' rule of signs. Yes, I got to hold you accountable for the rational root theorem. But let's talk about a way to functionally solve these kind of questions. So these are exercises from the textbook, and I'm going to try to do some of the. I'm going to try. I got three of these grafters, so I'm going to show you how to do these and still be behind the spirit of learning how to do doing this. So for that very first question, whoops, let's see, just a minute here. Let me undo what I just did. For that very first question on that exercise set was this function here. So I threw it into Desmos to graph it. I'm seeing one real zero. It only crosses the x-axis once. How do I know that this graph's not going to curl back around? Well, if you think about the leading term, and then the degree of this polynomial, I know this is a third degree polynomial. As I go out to negative infinity, this function is going to go down to negative infinity. As I go out to negative infinity on the x, this is going to go down to negative infinity on the y. That's not going to curl back around. And as I go out to positive infinity on the x, it's going to go out to positive infinity. That's not going to curl back around, because we know that's how third degree equations behave, third degree polynomials behave. So this is going to be the only real zero, and it's rational because it's 2. So if you think about that rational root theorem, remember how we do the factors of this last term, so plus or minus 1, plus or minus 2, over the factors of the first term, the coefficient of the first term, so that's just plus or minus 1. And lo and behold, 2 is one of the possibilities, and that's what we're seeing. Okay, so now how do you find the complex zeros here, the rest of them? Well, we know, here, let me move this out of the way. And I know that I've got, what is it? It's x cubed. Here, let me move around and look at another document here that I got open. It's x cubed minus x squared minus x minus 2. So then, since we know x equals 2 is a 0, because that's where it crosses the x-axis, y equals 0, x equals 2, Dan, we're going to do some synthetic division here. And what that'll do is our remainder won't include this factor. So x, negative 1, and negative 2. I'm not missing any powers of x, so that's good. So bring down the 1 and multiply and add and 2 and add and 2, and we get 0 remainder, which we knew it was going to be equal to 0 because it was a 0 for the function. So then what do we do? So that tells me, here, let me move this up out of the way, So that tells me I have x minus 2 times x squared plus x plus 1. We knew it's that because it was an x cubed and now it's x squared. We divided out that single x. So then we try to factor that. Well, we know it's not going to factor because the graph showed that it never crossed the x-axis again. So there's not going to be any real roots. So we're stuck using the quadratic formula here. So let me do a little magic here, moving things around. So a equals 1, b equals 1, c equals 1, and then to use the quadratic formula, negative 1 plus or minus, remember it's negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So 1 squared is 1, minus 4 times 1, all over 2 times 1. Well, underneath the radical, right? Where's my pointer? Underneath the radical, we're going to follow order of operations. So that becomes negative 4 times 1, which is negative 4. What's 1 minus 4? Well, that's negative 3, isn't it? Over 2. And we know we can't take the square root of negative numbers, so that's going to introduce an I. So negative 1 plus or minus I square root of 3, and the square root of 3 we can't simplify. And then that's the answer. That's the other zeros. Now, if they ask us to find list, how does it word? It says list, write the function as a product of linear and irreducible, or really quadratic factors, all with real coefficients. So this exercise set is actually asking us just to do this, but I know that the homework assignments are going to ask you to do a little bit more. So this assignment's just asking us, we actually did that up here. Do you see that? The assignment's saying to write it as a linear and irreducible quadratic factors. Well, that's an irreducible quadratic factor. So that actually meets this homework assignment, that this one on page 215, number 37. If they want us to write this, the solutions as a set of linear factors, then what we're going to do is this. So I know I've got x minus 2. This one becomes x minus, if we want, we can write -1 plus, not plus, or I'm just going to go plus the square root of 3i. I need the I over 2. And then I could do x plus -1. Actually, Dan, you're messing up. Just a minute here. Minus -1 minus I square root of 3 over 2. And that's where we get the two factors. Okay, yeah, I could clean up some signs there, but that's, so there's two ways to write the answer. The big thing, graph it, remove all those real zeros. If you're lucky and they're all real zeros, then that's good. If you end up with something with decimals that isn't like 1.5, then you got to do some more work. Of course, the rest of these problems here in the section are all have complex zeros. So we'll do a couple more here and see if we can't help you with them. So then the next function, whoops, let's undo that. Let me get my finger back here. So this next one, this was what? This was number 38. So I see it crosses at 2. So we'll do that same kind of thing. 2 into, actually, if you want, you can stop this video and try it yourself, then come back and watch the rest of it and see if we agree. So I'm going to divide 2 into 1, -1, 1, and -6. I'm going to get 2, which is 1, 2, which is 3, 6, which is 0. We knew it was a 0 because it told us that. So I'm going to get x minus 2 times x squared plus x plus 3. So there's that satisfies this homework assignment as writing them as an irreducible quadratic. Now I know this is irreducible because it doesn't cross the x-axis again. It's not going to factor, can't factor. So they're going to throw it into quadratic formula. Remember, a equals 1, b equals 1, c equals 3. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So -1 plus or minus the square root of, let's see, this is 1 minus 12, right? -11 over 2. So -1 plus or minus I square root 11 over 2. What a fun number, huh? And then, let's see, sorry, I had to stop the video I got to remember where I was at. Okay, so I think I've got, let's see. Yeah, I want to be able to drag. Come on. Let's see. So x minus 2. So for the linear factors, if I had to write this out as a set of linear factors, it'll be x minus 2. And then I'll write it as x minus 1 minus I root 11 all over 2. Or you could break those out separately. And then the other one would be x minus 1 plus I root 11 over 2. And that would be the set of linear factors. Two of them are complex, okay? Try one more. All right, so then this one, let's see. So I'm seeing a 4th degree equation. I know it's going to head this way and head this way, so it's not going to curl around. I see 2 zeros. So it must be that, remember the fundamental theorem of algebra says you're supposed to be 4 zeros. So we'll have to remove these 2 that we know and get the complex ones. Let's see here. So let's see, -4 is a 0, and we have what, 1 and 3 and -3 and 3 and -4. So do that synthetic division. 1, and then what do we got here? That's -4, which is -1. Why did I write, oh, that's a 4. Okay, so that's +4, which is 0, which we knew. And then since I know that +1 is also a 0, we'll just keep rolling with the remainder, right? We're trying to get this down to be x squared. All right, so that's 0, and that's 0, and that's 1, and that's 1, -1. So what do I have here? I have, so to make the assignment happy, let's see. To make the textbook happy, we have x plus 4 times x minus 1. And remember, those are coming from this. If x equals 4, the factor is x plus 4. If x equals 1, the factor is x minus 1. And then the non-reducible quadratic is 1x squared plus 0x plus 1. So that's factored. And so then actually this will be fairly easy. I don't even want to use a quadratic formula on that. I could, but for this one, when's that equal to 0? Well, x squared equals -1, so x equals, can I just jump to plus or minus I, and you know where that came from? Maybe I ought to write it out as the square root of -1, x equals plus or minus the square root of -1, and we know the square root of -1 can be written as I. So linear factors, so we've done this. So that assignment is that for a solution from the back of the book, if you looked in the back of the book, right? And then this would have, for a set of linear factors, would be x plus 4 times x minus 1 times x plus I times x minus I. Okay. So, I don't know, do we want to look at Descartes' rule of signs with this? I probably not. Give me a yell if you want, if you need some more help with that. I'll stop this video and get it uploaded.